Hey, welcome to a tutorial on 3D printed gears, and we're going to use Fusion to design these gears to fit onto 1/4 inch hole, 1 inch spacing, standard pegboard material you'd get in a hardware store and see in a workshop. So now we've got this requirement that we need gears to fit the gears that we currently have, and we can see here that they spin in proper ratio to each other, 25 teeth to 5 there, or 5 to 1. And we need to make another gear that meshes with these teeth, so it has to have the same teeth shape. And it has to have a center distance that is going to mesh with the 1 inch hole pattern there. So this is a 25 tooth gear. Its pitch diameter is 5 inches, so it's 2.5 inches this way and 2.5 inches this way. So that tells us that the mesh point here is a 1/2 inch from the center. So all of the gears are going to be they're going to be an odd number because they're going to be divided by 2 and land in between a 1 inch hole pattern. So let's head over to utilities, and we're going to go to add-ins, scripts and add-ins. And using the spur gear tool, we're going to make a spur gear, and we're going to add it onto this board. If we check the table that will be acceptable for this 1 inch increment that we've laid out, the diametral pitch is always going to be 5, and that is to say there's always going to be 5 teeth per inch, okay? Because here it's the number of teeth divided by the pitch diameter there. So 5 teeth divided by the diameter is 1, gets us back to 5. 25 teeth divided by 5 is also 5. So this is a function of the tooth shape, which means that all of the gears need to have this same pitch. So let's make a pitch diameter gear that is going to be 9 inches, and it's going to have 45 teeth. But we know it's going to fit and mesh with the rest of our gears. So back over to Fusion, we're going to use the English standard, and we're only using that today because the pegboard comes in an English or imperial increment of 1 inch holes. We'll keep the pressure angle at 20 degrees, and the diametral pitch we need to be at 5 teeth per inch. The number of teeth here will be 45, and here we can see the pitch diameter as 9 inches. Now the backlash, we're going to add a 0.1 millimeter backlash because we're targeting this for 3D printing, and that's going to add 0.1 millimeter of tolerance on either side of the faces of the teeth, just to make them a little bit more amicable to rotation and to take up any sort of extra material space that 3D printing has taken up, or in a real world application, sometimes that's space for lubricant or just play. Okay, so pitch diameter of 9. And now we're going to attach this to the pegboard here. So I'm going to need to use a joint, but actually based on where it has been created, it makes more sense to move this first as a component. I'm going to move the entire thing. That's important to do it as a component there because we want to move the origin of it as well. And I'm going to select it, and I'm just going to move it so that it's easier to see where it is and work with. Okay, so if I press J for joints, I'm going to select the bottom of the center of the gear. There we go. And now I need to select the correct hole here. So the diameter of our new gear is 9, so half of that is 4.5. And our existing gear diameter was 5, so half of that is 2.5. So that's going to give us 4.5 plus 2.5, that's 7 inches away. So I should be able to count 1, 2, 3, 4, 5, 6, 7 holes away. And I should see that the diametral pitch, or rather the pitch diameter for the two should be tangent now, as in the ideal mesh point is touching each other for both gears. So I'll accept that, and then I'll give this a rotation. It would help to look at this orthographically from the top. And I want to get the initial position for my simulation correct. I can see that I've got tolerance space there, and I should capture this position. Okay, so quick test, that's working, but they're not linked yet, so I need to create a motion link. Motion link asks for what joints am I linking. This revolute and this revolute. Now here I can use the number of teeth as my degree relationship, and I can also select that they're reversed because any odd set of gears, regardless of this other one here, any even set of gears is going to reverse direction, any even set. So my angle here, I think will be my first joint versus my second one. Okay, so with that in place, I can check it orthographically again, and I can verify that they're meshing in the right direction, in the right position, and at the correct ratio. Now when I rotate the top one, I can see that for every one rotation here, I should get quite a few over here, and vice versa. And actually it would be 45 to 5.